Hi everyone, this is Srikanth, Assistant Professor of Triple Department. In this session, I am going to discuss the problems on Norton's theorem. Now we need to calculate the Norton's equivalent for the given circuit. For this Norton's equivalent, we need to calculate Norton's current and Norton's resistance. Norton's theorem states that in any linear bilateral circuit, between the two terminals can be replaced with a single current source in parallel with the resistance, where current source is the short circuit current across the two terminals and the resistance is the open circuited equivalent resistance between two terminals by replacing the sources to zero. That means voltage source is replaced with short circuit and current source replaced with open circuit. Here, for calculating Norton's current, I am replacing the load resistance with a short circuit. And here I am replacing it as short circuit and I need to calculate the Norton's current. Here the 3 ohms, 6 ohms, 9 volts. So here IN is equals to, here short circuit is placed in parallel with the 6 ohms. So this will nullify this 6 ohms because when a zero resistance, short circuit is nothing but a zero resistance. When a zero resistance is in parallel with any resistance, that will make zero because the parallel resistance is equals to R1 R2 by R1 plus R2 and that value will become 0. So our circuit will become a 9 volts, 3 volts, 9 volts, 3 ohms and IN, where IN is the short circuit current, that is equals to 9 by 3, which is equals to 3 amperes. This is the Norton's current. Now let us go with the Norton's resistance. For calculating Norton's resistance, we need to replace the voltage source with short circuit and current source with open circuit. In our problem, we are having only a voltage source. So that voltage source is replaced with a short circuit and RN. Here it is 3 ohms and 6 ohms. So Rn is equals to 3 into 6 by 3 plus 6. That is equals to 18 by 9, which is equals to 2 ohms. So the Rn value is 2 ohms and IN value is 3 amperes. Now our circuit will become, this is the IN, which is in parallel with the resistance Rn, 2 ohms, 3 amperes, and then the load resistance RL. So IL is equals to IN into opposite resistance, IN into Rn by Rn plus RL. This is the formula used to calculate the load current. And here again the next problem. In this also we need to calculate the Norton's equivalent. So for calculating Norton's equivalent, I'm replacing with load resistance as short circuit. That is, here you need to calculate the Norton's current. 4 ohms, 6 ohms, 3 ohms, 18 volts. This is the V1. Here, in order to calculate the Norton's current, we need to calculate V1, or we can go with the mesh analysis. That is, I'm going with the nodal analysis. KCL at node 1. KCL at node 1, that is V1 minus 18 by 6 plus V1 minus 0 by 3 plus V1 minus 0 by 4 is equals to 0. If we take V1 common, 1 by 6 plus 1 by 3 plus 1 by 4, which is equals to 3. So V1 value is equals to 4 volts. Now the V1 value we got 4 volts. IN is equals to V1 by 4, which is equals to 1 ampere. Now we got the IN value as 1 ampere, and we need to calculate the Norton's resistance. So for calculating Norton's resistance, voltage source is replaced with short circuit. Here is the 4 ohms, 3 ohms, 6 ohms. RAB. RAB is equals to 4 is in series with the parallel combination of 3 and 6. 4 plus 3 into 6 by 3 plus 6, which is equals to 4 plus 2, which is 6 ohms. So now we got Rn and In value. If we know the Rn and In value, we can easily calculate the load current for different values of load resistance. Now we'll go with the next problem. And here we are having a current source. Previously we used to have the voltage source in the last problems. Now we are having a current source. Now let us see what is the difference which we are going to get here. That is, for calculating Norton's current, .4 kilo ohms, 120 milliamperes, 1.2 kilo ohms, 3.3 kilo ohms. This is our IN. Now we need to calculate the current flowing through the 3.3 kilo ohms is nothing but our Norton's current. So for calculating current flowing through 3.3 kilo ohms, now I am reducing the circuit into a smaller by using the equivalent resistance concept. Here, this 2.4 kilo ohms and 1.2 kilo ohms are connected in parallel. So the R equivalent is equals to 2.4 kilo into 1.2 kilo by 3.6 kilo ohms, which is equals to 0.8 kilo ohms. Now we got the R equivalent as 0.8 kilo ohms. Now this circuit can be replaced with a zero point 0.8 kilo ohms, that is in parallel with the 3.3 kilo ohms. This is 3.3 kilo ohms, zero point 0.8 kilo ohms. And here it is 120 milliamperes. Now we need to calculate, this is the current flowing through 3.3 is nothing but the IN value. So the IN value is equals to 120 into 0.8 kilo divided by 3.3 plus 0.8, which is equals to 23.41 milliamperes. Now we got the IN value, and in the same way we need to calculate the Norton's resistance by replacing the current source as open circuit, and the load resistance is also open circuit. Now RAB 3.3 kilo ohms, 1.2 kilo ohms, 2.4 kilo ohms. It is open circuited. So RAB is equals to 3.3 kilo plus 1.2 K is in parallel with 2.4 K, which is equals to 3.3 K plus 1.2 K into 2.4 K divided by 1.2 K plus 2.4 K, which we are going to get it as RAB or RAN. Rn is equals to 4.1 kilo ohms. This is the RAB value, and we can also write it as Norton's resistance. This is the way we need to calculate the Norton's current and Norton's resistance. This is our next problem. Here the load resistance is given. When the load resistance is given, we have to calculate the load current. So first let us go with the calculation of Norton's current. IN. For calculating Norton's current, I am replacing the load as short circuit. 2 ohms, 4 ohms, 6 ohms, and 8 volts. Here, the 6 ohms is connected in parallel with the short circuit, so this will be nullified. This will be nullified. So, our circuit will become 2 ohms, 8 volts, and 4 ohms. This is nothing but the Norton's current. So, the Norton's current is equals to current flowing through 4 ohms. 4 ohms is connected in parallel to the 8 ohms. So, IN is equals to 8 by 4, which is equals to 4 amperes. Now we got the Norton's current as 4 amperes. Sorry, 8 by 4, 2 amperes. Now we got the Norton's current, and then we need to calculate Norton's resistance. So ohms. Sorry, here this voltage source will be replaced with short circuit. So RAB we are going to get, that is 4 ohms, 6 ohms, and when it is short circuited, this 2 ohms will be nullified. So only 4 ohms and 6 ohms. Once this 2 ohms is nullified, our circuit will be, which is there is no 2 ohms here. When there is no 2 ohms, the RAB or RN is equals to RAB is equals to RN is equals to the 6 ohms and 4 ohms are connected in parallel. So 6 into 4 by 4 plus 6, that is equals to 2.4 ohms. This is the way we need to calculate the Norton's current and Norton's resistance. Now we need to replace the complete circuit into a Norton's equivalent, and we need to add the load resistance for calculation of load current. So here this is the Norton's current is in parallel with Norton's resistance and load resistance. This is 3 ohms. On Norton's current we got it as 2.2 amperes, and it is 2.4 ohms, and this is the IL value, where IL is equals to, by using the current division rule, 2 into opposite resistance 2.4 by 2.4 plus 3, which is equals to 0.88 amperes. The next one is we need to calculate what is the current flowing through AB terminals. That is, here are the load resistance terminals or AB terminals. Now we need to calculate Norton's current and Norton's resistance corresponding to the given circuit. For calculating Norton's current, I am making the terminals as short circuit. 10 volt source, 5 ohms, and it is short circuited. 5 volts, 10 volts, 5 ohms, 10 ohms. Now we need to calculate what is the IN value. So here, for calculating the IN value, we need to go with any of the circuit reduction method. So here we can replace the circuit like this: 10 volts in series with 5 ohms, and then 5 volts in series with 10 ohms, not like this. Here here it is completely short circuit. Whatever the current which is flowing from here and which is flowing from here will flow through the short circuit itself, because when we are having a short circuit, no current will choose a path other than the short circuit. So let us consider this value as I1 and this value as I2, where I1 is equals to 10 by 5, which is equals to 2 amperes, and I2 is equals to 5 by 10, which is equals to 0.5 amperes. So IN is equals to I1 plus I2, which is equals to 2.5 amperes. Now this is the IN value, and for calculating RN, the voltage source is replaced with short circuit and the load resistance is open circuited. 5 ohms and 10 ohms. Here RAB is equals to, these two are connected in parallel, that is 5 ohms into 5 into 10 by 5 plus 10, that is equals to 3.33 ohms. This is the RN value. Next, here the load resistance, which is given as 5 ohms. So we need to calculate Norton's current by replacing the load resistance, that 5 ohms resistance. So here let us replace, for calculating Norton's current, let us replace the circuit with a short circuit, that is here this resistance is replaced with the short circuit. Four amperes, 15 ohms, 10 ohms, 1 ohm, 2 volts. Here we need to calculate what is the Norton's current. Here, for calculating the Norton's current, in this session I have discussed the several problems on the Norton's theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.